recorded notes online also. So, lesson 1.4, solving multi-step equations. We're going to not necessarily follow, like any specific thing in the book. Just, follow along with me. So I'm just going to give you a little tip at the beginning here that there are a couple of different ways to first go about solving a multi-step equation. And we don't all have to go about it the same way. But I'm going to give you a tip that it is usually, and you want to put this tip in your notes, usually better, so we're working in pencil now, right? Usually better to undo addition or subtraction. Remember when we're solving, we do inverse operations, we undo. So better to undo addition or subtraction before multiplication or division. But of course I am going to, in the very first problem, I'm going to show you how to do, what happens if we do it either way. And the reason that I kind of make this point is because this is going to stop, it's not going to, why do I not end up with, okay, well, we're going to just hope it still just recorded that part right there. Or in order of operations, what do we do first? Do we add, subtract, multiply, or divide first? Which one comes first when you're following order of operations? Jared? You're adding or subtracting first? Not in order of operations. In order of operations, you actually multiply or divide before you add or subtract. But I'm kind of turning that around and saying if we're solving a multi-step equation, we want to do the reverse order. We want to take care of getting rid of the addition and subtraction first, and then the multiplication. Okay, so let's solve some problems here. The first one that we're going to solve, we're going to do it either way. We're going to follow my tip first of all, which says undo the addition or subtraction first. So this is the one we're going to follow the tip in. Okay, do you remember from when we were in lesson 1-2, if a negative number is being added, how do we undo that? Add the opposite. Yeah, so we're going to add, what are we going to add to both sides? 4, yeah, so we'll add 4 to both sides of this equation. Now you might have a little thing you do, like you divide it up like this so that it kind of keeps the two sides separate, or you might have your own method. What does the left side of the equation now read?
7x.
Okay, so 7x is what's left on the left side, and now what do we have on the right side? 7, okay. And now what do we have to do? Divide by 7. Okay, well this one, you can't really, it's a no-brainer. You can't really divide by the wrong thing because we've got the same thing on both sides, right? But not always do students remember that whatever is being multiplied by, that's what you need to divide by. So what's our solution? 1. X equals 1. Okay. Now I want us to, we should get the same solution, but I want to show you that if you decide that you don't want to take care of undoing the addition or subtraction first, which is what we did here, we undid the addition and subtraction first. We had additions, we undid the addition first. What if we don't want to do it that way? So what if we undo multiply or divide first? Okay, put that little note there. Because you don't want to think that every time you solve one of these problems you have to do it both ways. We're just showing what if you choose to do it the other way. What would it look like then? Okay, so what if we undo multiply or divide first? So we'll take the same equation, -4 plus 7x equals 3, and we're going to solve it doing a different step first this time. So we're going to undo the multiplication or division first. Anybody know what we need to do? Remember, the goal is to eventually have a 1x by itself on one side of the equation, doesn't matter which side, but we need it to be a 1x. So if we're going to undo multiplication or division first, what's x being multiplied by? 7. So we need to divide by 7. But here's the deal. If you choose to start by undoing multiplication or division first, and I don't want you to do it in this step, I want you to write this equation again. Just ditto. Okay, write it again. Every single piece of the equation has to be divided by 7. Every single piece of the equation has to be divided. If we were undoing division and we were multiplying, we would have to make sure we multiplied every single piece of the equation. Well, some of you starting to feel like this is getting ugly and you don't like the way it looks? Yeah, me too. Okay. So negative 4 divided by 7. Well, what's a negative divided by a positive? A negative. 4 divided by 7. Is that pretty? Okay, then let's leave it 4 sevenths. These cancel out, correct? And so now we have x. 3 divided by 7. Is that pretty? No, then we're going to leave it 3 sevenths. Okay, is x alone yet? No, we have this negative being added to it over here. What do we have to do to undo that? We have to add its opposite, which is 4 sevenths, correct? So we add 4 sevenths to both sides of our equation. Come on. And over here, that's gone. We have our x alone now, so we have x left over alone. What has to be true when you add fractions? What has to be true to add fractions? They have to have the same denominator. These guys do, don't they? So then what do we do since they do have the same denominator? Add their numerators. So 3 plus 4 is 7, so we have 7 sevenths. And 7 sevenths is the same as 1. Do we get the same solution? Okay, which one was prettier? First one, wasn't it? Yeah, we don't want to make it uglier. You don't want to create it so that you're like, oh, as soon as you see those fractions, you're like, why do I have fractions? It's okay to have fractions. I'm not saying it's a bad thing, but don't need to create them if we don't have to. So, we're going to pick one of these ways to do it, and typically we want the one that's prettier. So, do you understand what I'm asking? What I'm instructing you about here? Do you think you have to show it both ways solving every time? No. You pick one of them. You decide to undo the additions or subtraction first, the pretty way, or you decide to undo the multiplication or division first and maybe create a little bit more, work for yourself and not like it quite as well. Okay, do you have room left on that side of the notebook page where you can solve another one? Yeah. Okay, then let's do another one here. Okay, I want us to solve 1 5/10 equals 1 2/10 y, take away 5 7/10. Okay, why don't you go ahead and see if you can solve that one, since you now know that there are 2 ways, and you get to pick which way you want to do it, and see what you get for y. You can seek help from your table partner if you need it. Oh my goodness, I'm here to calculators, come on. Oh my goodness, really, this is that hard? Okay, let's try, come on, Lucy, stretch yourself, stretch, you can do it.
6.
If you didn't know there are 6 12s and 72, it's time to learn that. Your calculator knows it, you need to know it. Okay? Again, I can't, be around you all the time and make sure you're not using your calculator, but I'm encouraging you. And while you're in here, of course, I'm gonna freak out on you every time you take out that calculator, especially when it's, you need to make a good decision about when do you really need your calculator or not. That's my point. Okay, everybody get that solution? Are we all cool? Anybody have questions? You see I put my work up there. Anybody undo the multiply, that you would have to divide first? Anybody do the dividing first? That would have been a really ugly scenario this time, to divide first. I don't think you would have liked it. Okay, let's do, we have a couple more to do, so you can either flip to the back side of your notebook page if you don't have enough room to work another problem. The next one's going to take probably a little bit more space than these last couple did. Okay, so you decide where the room is. So we're doing another one in case you're still on the same page. We're going to do one with fractions. Yay!
Yeah.
There's our equation. Well, here's the thought process we have to have every single time we're going to work with fractions. If you multiply or divide with fractions, do you have to have a common denominator? No. But if you're going to add or subtract with fractions, do you have to have a common denominator? Yes. Well, there's a 1/2 being added there. Are we going to have to add or subtract?
Sure.
Yeah, we're going to have to subtract, aren't we? So before we even do that, because we're not going to use our calculators, we're going to rename this equation so that all of those guys have the same denominator. So what would be a common denominator for 3/4, 1/2, and 7/8? 8. How many 8s are 3/4? 6. Okay, so let's rename that 6/8 A. How many 8s is 1/2? 4. So let's rename that 4/8. And we don't need to rename the 7/8, do we? Okay, now it's going to be friendlier. Now we'll go to work and do our steps. Okay, what are we going to do first? Subtract what? 4/8. Okay, we have to subtract 4/8 from both sides. Our equation now reads 6/8 A
Equals 7. 3/8.
equals 3/8. Okay. Because 7, take away 4, 3, right? Okay, now what? Now we divide, but remember yesterday we said there's a shortcut for that? If the variable is being multiplied by a fraction, you can undo that with another multiplication. What is that? The reciprocal. So we're going to take both sides times 8/6. It's just prettier. Okay? Take both sides times 8/6. That's what we're doing here. This same thing on both sides, see? And what happens on the left side? These guys cancel out, right? And we have a. What happens over here?
Cross cancel.
Those cancel. And
3 and 6.
3 can become a 1 and the 6 can become a 2. And our answer is 1/2. That was not very painful at all, was it? No? Yes? Okay. Questions? Now would be the time to ask. Okay, we're going to do one more thing. I want you to look on page 35. On page 35. And we're going to do the check it out problem at the top of it's the one, check it out problem number 4. Okay. And so where we have Sarah paid $15.95. Everybody see where I'm at? Okay, so in our notes, we're going to mark that problem. So let's just make a note where we're at in our notes. Check it out. And we'll say top of page 35, that's where it's coming from. And it is number 4. Okay, read through that problem to yourself. Is there something we're solving for? How much is the monthly fee? So typically what we're solving for will become our what? Variable. It's our unknown, isn't it? Since it's our unknown, so we have to pick a variable. Let's start there. What variable do you want to use? X. Okay, cool. So we're going to say X is the monthly fee. Remember I said we're going to get in the habit of identifying what our variable is representing. So X is the monthly fee. Well, now let's set up an equation with the information that's useful with this variable that'll help us solve this problem. Because you can solve this problem without setting up an equation. Trust me, you can. I know that. I'm very well aware of that. But we have to get used to being able to set up an equation, an algebraic equation, to solve it. So anybody want to take a stab at it? Jacob.
12x plus 15.95 equals 735.95.
Okay, it's 12x plus
15.95
okay,
equals $735.95.
$735.95 then? Is that what it is? Okay. Well, let's evaluate this. Let's tear this apart and see if we think this would work. So what is first of all, that's a really big number. I want to know what that's representing. What is that?
Total cost.
Total cost for what?
12 months.
For 12 months? Okay, so for a whole year. Okay. What is the $15.95? What's that?
Membership.
For membership.
Membership fee. How many times do you have to pay the membership fee every month?
Once.
Once. Typically a fee is one time, right? A fee to join or whatever. Okay, so you only pay that one time, so that's why we only want it added in there once. Okay, then tell me what's the 12x representing?
12 months.
12 months.
And the x is the amount of money paid per month.
Okay, so then what is 12x?
That would be the total cost except for the membership fee.
Yeah, that'd be all the rest of your cost, right? Except for the membership fee. So that, what you pay every month, all added together, and we shortcut it by multiplying by 12, that plus that membership fee should add up to the total amount that was spent. So this looks like a good equation, right? Do you agree? Hey, let's solve it. Go ahead, solve it. This should be one of those, might let you resort to using your calculator. Try, see if you can challenge yourself to no calculator, but I think you can. Really not that hard. They use friendly numbers. Look at there's that 12 and 72 again. Huh. 6. Yeah. But then we got that 0, don't we? So I can ditch these guys, can I? Yeah. Okay. And so x equals 6 goes in there 6 times. We got that 0 there, so 60. And what is it? 60 what? Dollars, because it's a monthly fee, isn't it? So we want to make sure we give a label to it. Okay. So, if you have any word problems to do in your homework tomorrow, what do you suppose I'm going to expect? Same thing we did here. What's your variable representing? Set up an equation with that variable in it, solve it, and make sure you give a label to your answer. So what is that 60 representing? Okay, you can get started on your homework.